frequency band classification is the frequency is classified into high frequency, very high frequency, ultra high frequency, L band, S band. The frequency band designation is done in the form of alphabetical nomenclature. That's why here you see the L band, S band, C band, X, K bands. Okay. So the L band, S band, C, X, and the K band is further classified into KU, K, and KA band. And finally, we have the MM band and the SM band. So the high frequency ranges from 3 to 30 kilohertz, and next very high frequency from 30 to 300, and 300 to 1 gigahertz is UHF, and L band is 1 gigahertz to 2 gigahertz. So this is in order of gigahertz. Okay, always microwave frequency range is in the order of gigahertz. Please keep this in mind, because in the lab when you are conducting the experiment you will be noting down the frequency and you will calculate the frequency. So always the frequency band is in the range of is in the order of gigahertz. Gigahertz is 10 to the power 9. Okay, if you want to write gigahertz, you'll write it as 10 to the power 9 hertz. Please keep these things in mind, because when you are solving the numericals also, the final answer has to be kept in the gigahertz range. So it will be gigahertz. So L band frequency is 1 to 2 gigahertz, S band is 2 to 4 gigahertz, and C band is 4 to 8, X band is 8 to 12 gigahertz, and K band is between 8 to 27 gigahertz. So, 18 to 27 gigahertz. And the frequency whichever is above 300 gigahertz are called as sub-millimeter frequency. Okay. So, this is the frequency band designation. And secondly, coming for the microwave systems. So frequency band designation, it's only for your knowledge. And in the examination, as of now, the frequency band designation table is not asked. But suppose if they ask also, it would be for 3 marks or 4 marks. Write down the frequency band designation of microwave range. So this table you have to write, and on the right hand side you will be writing the frequency range, and a short 2 to 3 lines of explanation will fetch you 4 marks. Okay, so that's it about this topic. And coming for microwave systems, or as in simple way we can also call it as a microwave test bench. Okay, test bench. It is called as test bench. It can be called as test bench because whatever the parameters that we want to analyze for a microwave signal, that is analyzed using these devices. That's why we can call this as microwave test bench. Because in your lab, you will be working with this test bench practically. You will be handling all these devices. Okay. So, but in your theory, this topic was explained as microwave system. A microwave system is a system which consists of the microwave passive devices and the active devices, where the parameters of a microwave signals like frequency, wavelength of the VSWR can be calculated. I'll repeat again. A microwave system is a setup which is composed of passive devices and active devices, microwave passive devices and active devices, which enable us to analyze the parameters like parameters of a microwave signal like frequency, wavelength, and voltage transmission ratio, voltage standing wave ratio (VSWR), and power of the microwave signal. Okay, this is what we call it as a microwave system. And coming for the explanation of the microwave system. A microwave system basically consists of a microwave source, the wave meter, or as I can call it, also call it as frequency meter. This is how we call it in lab. It is frequency meter. Next, attenuator, And to analyze a microwave transmission, here in the diagram they are given two antennas. One is the transmitting antenna and the receiving antenna. And finally, we have the output device where we can connect it to the oscilloscope, or else one more device which we normally use in your lab is VSWR meter or power meter. And the output at the final output is normally terminated. Terminator means in the low frequency circuits we will connect a load resistor, right? In the same way, in a microwave test bench also we terminate the waveguide by connecting a terminator. So this is what we call it as termination. So, a microwave system normally consists of active devices and passive devices like microwave source. The second is wave meter, microwave source, wave meter or frequency meter. Next, attenuator. This is on the transmitter side. This is on the transmitter. And here is a system for transmitting the signal. That is, here I am making use of an antenna, which is one of the device which is capable of transmitting microwave signal. Okay, so here in the diagram, the author has given transmitting antenna, where the type of the antenna is an horn antenna. Okay, and coming for the receiver side, because as you know, any communication system consists of a transmitter and a receiver where the channel is in between. So here the channel is the antenna, that is the horn antenna. So one antenna we are using on the transmitter end and the other antenna we are using on the receiving end. So on the receiver, the horn antenna is there, where this horn antenna is finally the output of the horn antenna is connected to a oscilloscope, and also in parallel we connect it to the VSWR meter, or else we connect it to the power meter, so that by means of oscilloscope we can calculate the different voltages and currents of the voltages of the micro signal where it is very high voltage, and using power meter we can will be able to measure both the power as well as the voltage standing wave ratio. Okay, so let me start explaining about this in detail. What is a microwave source? So as we have studied in part A of module 1, we have studied about klystron amplifier, klystron oscillator. So this is one of the microwave source which we make use in your lab. The microwave source. The microwave source is normally the klystron power supply. It generates a microwave signal. Okay. So microwave source is normally the klystron power supply. And after that we connect a wave meter where the wave meter is the one which detects what type of wave it is getting transmitted, or it can also be called as a frequency meter because it displays what is the frequency of the signal that is getting transmitted, because this is a waveguide structure which is a hollow structure. Okay, and inside this waveguide structure the electromagnetic signals will get transmitted, or as the microwave signal will get transmitted. So when the signal goes through the wave meter, flows through the wave meter, it displays what is the frequency of the signal. And after that, at this point of time, we can measure what is the frequency of signal. And secondly, in continuation, the signal also will propagate through the attenuator. And an attenuator is a microwave passive device which partially attenuates or partially absorbs the microwave signal that is getting transmitted. Attenuator is the one which reduces the input power level. How does it reduce us? It drops down the power. It absorbs the input partial power and remaining 50% of the power is transmitted further. Okay, so that is what we call it as an attenuator. An attenuator absorbs the input signal partially and allows the remaining signal to propagate further. And from the attenuator, the input is given to the antenna. That is, here we are making use of a on type of antenna. So whenever the signal is allowed to transmit through the antenna, now the signal will radiate into atmosphere, and that signal is once again received at the receiving antenna, which is once again the same type of antenna, that is on antenna. And the output of the on antenna is connected to the power meter or and also the oscilloscope in dual connection. Okay, and the output is always terminated by means of a waveguide terminator, because the reason is that if you don't terminate the power at the output terminal, then the power gets radiated into free space. That is the reason why we should terminate the microwave system at the receiver end. Okay, so this is all about microwave systems, and these are what we which we call it as stand, because the microwave devices are very huge, it is complex, it is heavy. Like suppose when you are connecting a circuits, when you are doing connections in circuits lab, where you are connecting transistor, resistors, capacitors, everything. The board is simple. You make use of a spring board, you connect the components on the board, you just do the testing. But microwave test bench is not like that. It consists of devices which are heavy. Okay, you cannot handle all the devices in one single hand. So that's why what to do is we try to mount it up in a as a bench, and we make use of the stands for mounting this. I have the photo of this setup, which I'll show you now and explain. Just I'll be sharing the photo of this, which has been taken in the lab, so that it will be easy for you when you go for the lab. Please just confirm me whether the photo which I display is visible to you. Okay.
Yes, ma'am, it's
Yeah.
very.
Okay. So now here, this is the microwave test bench. Uh, One sec. I'll just check whether I have some other clarified signal. Okay. So here this is the setup, which is a microwave test bench setup. Okay. So the microwave source, please have the comparison in the block diagram. That's the purpose why I told you in yesterday's class also to have a notebook with you. The first thing is microwave source. So the microwave source is klystron. The microwave source is klystron tube. Yesterday's class I explained you about the klystron tube. So that is the klystron tube which acts as a microwave source in the microwave test bench. And here itself you can see it is not as simple as you handle a resistor as a transistor in the lab. The devices what you are seeing is huge. Okay, so this first one is the klystron power supply which generates the microwave source, and after that the black terminal what you are seeing. Okay, the black type of case, that black device is attenuator. Okay, and the next one is the frequency meter, and below whatever the gray type of light blue or gray type of device that you are seeing, they are called as microwave stands. So this are called as microwave stands. Okay, two light blue color terminals you are able to see, right? They are what we call it as microwave stands. It acts as a supporting pillar for the devices which is connected. And the green type of thing and the green layer and the black layer what you are seeing, they are what we call it as waveguides. A waveguide structure, a waveguide structure is the one which allows the micro signal to travel. The wave is guided continuously, and this is what we call it as wave meter. The black one is attenuator, that is variable attenuator, and the uh, circular disc type of mount what you are seeing is wave meter. And this is the what we call it as, or which we call also call it as frequency meter, where by rotating this you will be you are knowing what is the frequency range of the signal that is traveling in the waveguide. Okay, so this is about the wave meter. And this is what we call it as a slotted line carriage or a detector. Here what we do is the waveguide is continuously connected, and the last gray type of thing which you see is once again the terminator. We will stop the propagation of the power. So from the detector we give one cable to the CRO and the other cable to the VSWR meter. This is the VSWR meter which you make use in the lab. So this VSWR meter is the one where we can measure the standing wave ratio, and we can also measure what is the power. Okay, this is something like dual meter, where by changing the knob positions you can measure the SWR value and also you can measure the power. This is a digital meter. Directly when you connect, you will have the display of the value. Okay, so this is a klystron mount which I explained you in yesterday's class. And the gray colors whatever you are seeing, that is the stand. Okay, I have few more diagrams which I can show you. So this is what we call it as a microwave guide. This is the attenuator which you'll be using in your lab. So this is a waveguide structure. As you know, as you are able to see, it is huge. Means it has to be connected with complexity. And this is one of the variable attenuator which you'll be using in your lab. And these are the waveguide tees which I'll explain you further. Still we have so many things to be done. So when I explaining about the microwave passive devices, I'll explain all these devices with you. This is the Dashan coupler. So these are all microwave passive devices which you will connect. Okay. So these are the devices, microwave passive devices, where all these devices you learn in this subject. And this is what we call it as mass terminator. Like how you connect a decayed resistance box at the end of the terminal to get the load resistance value, or a load resistor in the low frequency circuit. In same way, in microwave frequency circuits, you will be connecting this. This is a mass terminator which stops the further propagation of the power. Okay, this is what we call it as a twister. Okay, and this is the horn antenna. In the microwave test bench, now which are the topic I was explaining. I showed you about the and I told you about the on antenna. This is the on antenna. This is once again a waveguide structure. Okay, and the shape of the on antenna is in the shape of on. That's why this is called as horn antenna. And in your theory, you will be studying about this on antenna also. The types of on antennas. Okay, so this is the on antenna which is connected, and this is the parabolic antenna or as the dish antenna. These are all called as dish antennas. Okay, and all these devices you have in your lab, and this is set up how we can do for a micro test bench. Okay, the same thing what I have represented in block diagram, right? The same thing is connected here. Yeah, the stand where you connect the transmitting antenna and the receiving antenna. Okay, and this is the SWR meter. This SWR meter is the one where we can measure the standing wave ratio and also you can measure the power. Okay, these are all the devices which you will be working with in your communication lab. Okay, so if you learn the things properly in microwave class, then it will be easy for you to understand the communication systems lab. Okay, so please learn the concepts which is explained in your microwave subjects properly. So got it? The microwave system is a system which is used to analyze the various parameters of a microwave signal. Basically, it is a test bench which consists of active and passive devices connected in the test bench. Okay. Among this, the microwave source is the active device. Other than that, the wave meter, the attenuator, the antennas or the passive devices which helps in the propagation of the microwave signal in the microwave guide structure. Any clarifications with these 2 points which has been explained? I have just explained two topics, the classification of microwave frequency and secondly the microwave test bench. And expected question is here this question may be asked for about 7 to 8 marks where it is explain the microwave systems with block diagram or is explain the microwave system. Okay. Only once this question was asked in part 1 of module A itself. Module in part A of module 1. That is question number 1 B or 1C this question was asked. Okay. So what the answer which you have to write is you need to write the block diagram, and after writing the block diagram then you are supposed to explain, you will have to define what is microwave system and then you'll explain about the components. That is, you'll explain about microwave test microwave source, wave meter, attenuator, the antenna in brief, and the output, oscilloscope and other things.